Our first MCQ is this: a ball falls through a liquid at constant speed. It is acted upon by three forces: an upthrust, a drag force, and its weight. The liquid has uniform density. Which statement is correct? The drag force increases with increasing depth? No. The drag force is equal to the sum of upthrust and weight. See, if a ball is falling down, where will the drag force act? The drag force will be acting upward like this. Where will the upthrust act? Upthrust will also be acting upward. Where will the weight act? Weight will act downwards. Weight must be equal to upthrust plus drag force. Hence, option B is also incorrect. The upthrust is constant with increasing depth. C is the correct answer. Although this might seem counterintuitive at first, but let me clear out one thing here. Let's say this is a beaker of water. Let's say this is a beaker of water and it is filled till here. If you place a ball here, or if you place a ball, let's say, one second, let me replicate this. Control copy. Yep. If you place a ball either at the surface or if you increase the depth of the ball somewhere here, the water is still being here. The upthrust at both these points, let's say this is point X, let's say this is point Y. The upthrust at point X will be equal to the upthrust at point Y because upthrust doesn't depend on depth. What was the formula of upthrust? Upthrust is equals to the density of the fluid multiplied by the gravitational field distance multiplied by the volume of the object. Now, when does upthrust change? Upthrust would have changed if upthrust would have changed if only half the ball, if only, let's say this is your water and let's say this is your ball. Can you see only half the volume of ball is immersed in water? Let's say this is position Z. Here the upthrust will be less. The upthrust at Z will be less. Why? Because the volume immersed inside the water is less. Hence the upthrust will be less. So this is something that you need to remember. The upthrust at U will be equal to the upthrust at X and both of them will be greater than the upthrust at Z. Because the upthrust at Z, you can see only half the volume of the ball is immersed. Hence your upthrust decreases. Simple as that. If you want to write this as a key point as well, you can write it as well. Upthrust increases until the entire volume of object is immersed in water, Next key point: once the complete object or once the entire object is immersed in water, then upthrust remains constant with depth. This is a detailed discussion on upthrust. Remains constant with depth. Simple. Let's further move ahead to the next question. Okay. Two cylindrical objects X and Y are held fully submerged in a liquid as shown. Perfect. The objects have the same volume. Perfect. So the volume of X is equals to the volume of Y. The density of the material Y is twice the density of material X. Perfect. Both objects are stationary. Perfect. Which statement is correct? One thing that I can observe here is that upthrust at X will be equal to what? The density of this liquid. The density of this liquid. Let's say that is rho L. The density of this liquid gravitational field strength into the volume of X. And the upthrust on Y will be what? Density of the liquid gravitational field strength into the volume of Y. Can you realize both are in the same liquid? Hence both have the same density, both have the same gravitational field strength. And here it is given that volume of X is equals to volume of Y. So volume of X and Y are also same. So both X and Y will be experiencing the same upthrust. C is your answer. In an experiment, a metal ball is dropped into a viscous liquid. The terminal velocity of the ball in the liquid is measured. Perfect. The experiment is repeated 4 times. For each repeat, a change is made to one of the following. Okay. The density of the metal ball, the height from which the ball is dropped, the density of the liquid, the depth of the liquid. Which two changes separately affect the terminal velocity of the ball in the liquid? Okay. So a ball is falling in a viscous liquid. What will be the forces here? There will be one force of weight acting downward. Since the ball is moving downwards, there will be a viscous force upwards, viscous drag you can say, and there will be an upthrust acting upwards. Now, when will you reach terminal velocity? When will you reach terminal velocity? You will reach terminal velocity when viscous drag plus upthrust is equals to weight. Now, any of these changes, if any of these changes affect either the viscous drag, upthrust, or weight, then they will be affecting the terminal velocity. Let's check them out one by one. First of all, density of the metal ball. From the looks of it, density of the metal ball might not affect any of the factors here. But do you remember that weight can be written like this? Density of the object into gravitational field strength into volume of the object. Can you realize this density? This density is the density of the metal ball. Yes, so if you change the density of the metal ball, the weight will change and hence the terminal velocity will change. So 1 is a factor that we will be considering. So option C and D gets cancelled out. Perfect. The height from which the ball is dropped does not matter. The density of the liquid also matters. Why? Because the formula of upthrust was what? Density of liquid G into volume of the object that is immersed. Can you see density of the liquid affects the upthrust? If it affects the upthrust, it will affect the terminal velocity reached. So B is your answer. Okay, let's see this question. An object of weight W is suspended from a Newton meter. When the object is completely immersed in water, the Newton meter reads P. When the object is completely immersed in oil, the Newton meter reads Q. Perfect, perfect, perfect. What is the ratio of the density of oil divided by the density of water? Okay, you have to calculate the ratio of the density of oil divided by the density of water. Very easy. If you analyze this first diagram, what is happening? You have one upthrust key force, you have a tension P, and you have a weight acting downwards. Perfect. You can write it down here. The upthrust due to water plus tension P is equals to weight. The upthrust due to water is equals to weight minus P. How can I represent upthrust due to water? Density of water into G into volume of the object immersed is equals to W minus P. Perfect. Let's do one thing. Let's make density of water the subject here, W minus P over G into volume of the object. This is your first equation. Simple. First equation. Let's try out with this Newton meter. There is a tension Q acting upwards, there is an upthrust of oil acting upwards, and there is a weight acting downwards. So apply the same logic. Q plus upthrust of oil is equals to weight. Okay. Upthrust of oil is equals to what? Weight minus Q. Perfect. Can you break down upthrust of oil? Yes. Density of oil into G into volume of the object is equals to W minus Q. Simple, simple, simple. Okay. Density of oil is equals to W minus Q divided by G V naught. This is your second equation. What do you have to calculate? You have to calculate the density of oil divided by the density of water. So let's divide these two equations. Let's divide equation 1 and 2. Perfect. So W minus Q divided by G V naught, that is the density of oil, divided by the density of water, that is what? W minus P divided by G V naught. GV naught, GV naught. Cancel out. W minus Q, W minus P is your answer. D is your answer. If you check in the marking scheme, 6 has an answer of D. Simple as that, nothing complicated here. A solid block has side of length L, 2L, and 4L. The block is submerged in water of uniform density so that the faces with the largest area are horizontal. Okay, so the face with largest area is horizontal. The upthrust acting on the block is U. Perfect. The block is now rotated to a new position, somewhat like this. The block is now rotated to a new position, and the surface with the smallest area is now facing water, somewhat like this. Perfect. So the surface with the smallest area are horizontal. Okay. The block is fully immersed in water. What is the upthrust on the block in the new position? A trick question, but if you realize upthrust depends on what? Density of liquid, G, and volume of the object immersed. In both position 1 and 2, the volume of the object that is immersed in water remains same. Density of liquid remains same. Gravitational field strength remains same. So both at position 1 and 2 we will have the same upthrust, that is U. B is your answer. A box in the shape of a cube falls from a ship into the sea. Perfect. The box lands with its lower face level with the surface of the sea. The box begins to sink, becomes totally submerged, and then sinks deeper into the sea. As the box sinks, its lower surface is always parallel to the sea. Perfect. Which graph best represents the variation of the upthrust acting on the box with the depth of its lower surface below the surface of the sea? Perfect. So, first of all, can you realize as soon as this block will start going inside the water, the volume of the object immersed will increase, the upthrust will increase. So the upthrust will increase for a certain amount of time. B cannot be your option, that's why. B cannot be your option. Why? Because as you keep on lowering this cube, this volume of cube will start getting inserted into water. Its upthrust will increase. Perfect. Now there will come a time, when the block is fully immersed. Then even if you increase the depth, the upthrust remains constant. So we need an upward sloping line and then a constant horizontal line. A cannot be your answer. C will be your answer. The logic behind it, I have already explained it in question number 1, I guess here. Your upthrust increases with the volume of the object immersed until the entire object is immersed in water. And once the entire object is immersed, the upthrust remains constant with depth. Simple. Let's move here. A block of wood has density rho W, side A. The block is immersed in a liquid of density rho L. Perfect. The top surface of the block is at a depth of h below the surface of the liquid. The acceleration of free fall is g. What is the upthrust acting on the block? We have to calculate the upthrust. Upthrust is the density of the liquid, that is rho L, into the gravitational field strength into the volume of the object, that is A into A into A. So the upthrust comes out to be what? Rho Lg A cube. Which answer is this? A is your answer. A spherical object falls through water at constant speed. What does the keyword of constant speed means? That means upward forces is equal to downward forces. Three forces act on the object. Which diagram shows these three forces to scale is correct. Perfect. Now diagram A, diagram D, and to some extent diagram C can be cancelled out right off the bat. Why? Because my upward forces should be equal to the downward forces. In part A, the arrows of upward forces are much larger than the downward forces. In part C and D, the arrows of downward forces are much larger than the upward forces. The only remaining option is B. Also, if you can't visualize this, what you can do is you can measure these lengths with a scale. Let's say this is 6 centimeter. This will be, let's say, 3.5, and this will be 2.5. So the length should equal one another in the up and down direction. A submarine is in equilibrium in a fully submerged position. Perfect. What causes the upthrust on the submarine? Okay. Why was the upthrust force being generated? Does anyone remember the theory? Due to change in pressure or the difference in pressure between the top and the bottom surfaces. Is there any option like that? D is your answer. Let's try this question out. A cylindrical iceberg of height h. Okay, so the total height is h, floats in seawater. What does the keyword of floats tell you? The keyword of floats tell you that the upward forces are equal to the downward forces. The top of the iceberg is at a height h above the surface of the water. Perfect. The density of ice is rho I and the density of seawater is rho W. What is the height h of the iceberg above the seawater? Okay. We basically have to calculate the height h. How will we do that? Okay, very easy. So the weight acting downward on the iceberg will be equal to the upthrust. Why? Because the iceberg is floating inside water, seawater, you can say. So, first of all, you will say upthrust is equals to the weight. Perfect. Now, let's start finding the weight. Let's start finding the weight of this iceberg. How can I find the weight of this iceberg? Very, very easy. Weight is equals to density of ice into gravitational field strength into the complete volume of the object. So I can write weight is equals to density of ice into G into the cross sectional area A multiplied by the complete height. Because in weight, always remember in weight, this volume V is always the complete volume. This V is always the complete volume. Please, please, please remember this. Now let's move on to the upthrust. Upthrust is equals to what? Density of water or fluid multiplied by gravitational field strength multiplied by the volume of the object that is immersed. This is what? Volume of object immersed in water. This is volume of object immersed in water. Immersed in water. Perfect. How can you calculate the volume of object immersed in water? Basically, what is the volume of object immersed in water? This thing. This thing. Okay. How can you calculate this? How can you calculate this yellow volume? Any ideas? Any geniuses who can tell me how can we calculate this yellow volume? Very easy. Density of water into gravitational field strength. Volume can be broken down into what? Area multiplied by what will be the height. This height is capital H minus small h. So let's multiply it here. Capital H minus small h. So now, unknowingly, you have derived an expression for weight and you have derived an expression for upthrust. Let's plug it in here. So, upthrust is equals to density of water into gravitational field strength into area into capital H minus a small h. Weight is equals to what? Density of ice G A H. Is anything getting cancelled out? Yes. Gravitational field strength in area, gravitational field strength in area. Perfect. Now let's multiply density of water with capital H, then density of water with a small h. Let's do that. Density of water, capital H, minus density of water, small h, is equals to density of ice, capital H. Perfect. Now you have to make this h as your subject. So let's take it to the right hand side. Density of water, capital H, minus density of ice, capital H, is equals to density of water, small h. Now, what can you do? You can take capital H common here. Density of water minus density of ice is equals to density of water into H. Now, let's bring this density of water into the denominator. Let's do that. H density of water divided by density of water minus density of ice divided by density of water is equals to your small h. This gets cancelled out. What will be your final answer? H 1 minus density of ice divided by density of water is equals to small h. Any answers like that? A is your answer. Simple. This was a lengthy question. Do go through it again if you found it difficult and tell me in the comments if you have any questions further. Okay, let's see this. A cylindrical block of wood has cross sectional area A, weight W. It is totally immersed in water with its axis vertical. The block experiences pressure PT and PB on its top and bottom surfaces, respectively, which expression is equals to the upthrust. Upthrust is equals to the change in pressure into area. What will be a change in pressure? Pressure at the bottom minus pressure at the top into area. C is your answer. Okay, let's see this. A solid sphere at constant terminal velocity in a liquid. The three forces acting on the sphere are shown in the diagram. Perfect. How are the three forces related? First of all, we are moving at constant terminal velocity. That means up forces equals to the down forces. What will be the up forces? Drag plus up thrust is equals to weight. Drag plus up thrust is equals to weight. Okay, you don't directly have that, but if you maneuver this equation, you take this to the right side, weight is equals to drag plus up thrust. C is your answer. Let's see this. A metal cylinder is suspended vertically in equilibrium by a cord. The diagram shows the cylinder in four different positions, P, Q, R, S. Which statement explains the variation of tension in the cord? At P and at Q, the tension in the cord is same. At P and at Q, the tension is in the cord is same. This is possible because the upthrust is same. Because the difference in pressure, yes, A is the correct answer. Because at P and Q, your cylinder is fully immersed. Hence, the upthrust at P and Q will be same. The tension in P and Q is same. Okay, let's read this out. A sphere falls from rest through air. The graph shows the variation with time t of the sphere's velocity. Perfect. Which diagram shows the forces acting on the sphere when its velocity corresponding to point P on the graph? Perfect. So when the velocity is point P on the graph, what will be the forces acting? Can you see on point P, your velocity is increasing? That means your downward force, that is weight, will be greater than air resistance. C is your answer. In all other cases, either air resistance is larger, either there is no air resistance present, or air resistance is equals to weight. Hence, all of the other options are incorrect. Let's try this out. A crane has an arm to which is attached a frictionless pulley. A cable passes over the pulley and supports a load of 10 kilonewton as shown. Perfect. The crane arm exerts a force F on the pulley. Okay, this is force F on the pulley. What is the value of force F? We have to calculate the value of force F. What can we do? We can resolve these diagonal forces. Let's resolve these diagonal forces and calculate these components. Let's calculate these components. Okay, what will these components be? This will be 10 into 10 raised to the power of 3 due to kilo into cos 30. This will also be what? 10 into 10 raised to the power of 3 cos 30. Simple. Let's calculate this answer. 20 into 10 raised to the power of 3 into cos 30. Simple. 17320. D is your answer. Simple. A child on a sledge slides down a hill with acceleration A. The hill makes an angle theta with the horizontal. Perfect. The total mass of the child and the sledge is m. The acceleration of free fall is g. What is the frictional force? You have to calculate the frictional force. Perfect. So if I examine this child, what is happening here? There is a resultant force. There is a resultant force that is equals to what? Mass m into the acceleration a. Perfect. What is the forward force? The forward force is mg sine theta. Backward force is friction. So let's place it in place of resultant force. Mg sine theta minus friction is equals to ma. Bring friction to the other side. Mg sine theta minus ma is your friction. Let's take m common. G sine theta minus a is your friction. Any answers like that? C is your answer. Let me check this as well. 30 ka answer should be C, and it is C. Perfect. A sphere is released from rest in a viscous fluid. Which graph best represents the variation with time t of the acceleration of the sphere? We have to tell how the acceleration varies in a viscous fluid. Very, very easy. You would be starting from a maximum value, let's say 9.81, and you will be decreasing to 0. As you reach here, you will reach terminal velocity. So D will be your answer. 40 ka answer should be D, and D it is. Okay, let's see this. A force F is applied at an angle of 45 degree to a door handle at a distance D from the pivot of the handle as shown. Perfect. What is the moment of the force about pivot? Perfect. We have to calculate the moment of the force about this pivot. So first of all, let's resolve this force. Let's calculate this component of the force. This will be equal to what? F cosine 45. What is the distance? D. So F cosine 45 multiplied by the distance D. This gives you an answer of what? FD over under root 2. A is your answer. Let's see this. A minimum torque of 20 Newton meters must be applied to the lid of a jar for it to open. The radius of the lid is 4 centimeter. What is the minimum force that must act on each side of the lid in order to open it? Perfect. So what must be the minimum force on each side for it to open it? Torque is 20 Newton meter. What will be the perpendicular distance between the two forces? The perpendicular distance is 4 centimeters. Total distance is 8 centimeter. So 20 is equals to force into 8 centimeter, that is 0.08. Your answer comes out to be 20 divided by 0.08. This is 250 Newton. C is your answer. Let's see this. A rod is pivoted at O. Perfect. A force F is applied to the rod at W. Perfect. As shown. Perfect. What is the moment of force F about O? We have to calculate the moment of force F about O. Whenever a force is acting diagonally, you extend the force and you drop a 90-degree line from the pivot to the force to calculate what? To calculate the perpendicular distance. So this OY will be your perpendicular distance multiplied by force will give you the moment. B is your answer. So yes, let me check in the marking scheme as well. B is the answer. Perfect. Okay, let's see this question. A square board of side length x, perfect, hangs freely from a nail P as shown. The board has uniform thickness and it is made from a material of uniform density, perfect. A second board of side length 2x is made of the same material and has the same thickness as the original board. The second board is hung from a nail Q. Nails P and Q are at the same height. What is the vertical distance between the position of the center of gravity of the two boards? Okay, we have to calculate the positions of distance difference between the center of gravity of the two boards. Perfect. So first of all, let's calculate the center of gravity of this P. First of all, let's calculate this hypotenuse. How will we calculate this hypotenuse? X square plus x square under root is equals to your hypotenuse. Hypotenuse comes out to be what? Under root 2x. Okay. If this entire length is under root 2x, where will your center of gravity lie? In the middle. So, how much height will it have from P? It will have a height of under root 2 over 2x. So, you can write here under root 2 over 2x will be your height from P. Now, let's calculate the hypotenuse of this Q. Let's calculate the hypotenuse of this Q. Okay. This will be what? Hypotenuse is equals to 2x whole square plus 2x whole square. This comes out to be x under root 8, which further gets divided into what? 2 under root 2x. Perfect. Now this entire length is 2 under root 2x. Where will the center of gravity lie? The center of gravity will be at a point of what? 2 under root 2 divided by 2x. Perfect. Can you calculate the difference between the two distances? Yes. 2 under root 2 over 2x minus under root 2 over 2x. They will get cancelled out. What will remain? Under root 2. I can write it here instead. Under root 2 over 2x will remain. This will be your distance between the two center of gravities. However, you can't see any option like this here. So here you need to remember a mathematical rule. Under root 2 over 2 is equals to 1 over under root 2. So you can replace this by what? You can replace this entire thing by what? 1 over under root 2. Your answer becomes what? 1 over under root 2 into x. B is your answer. A horizontal metal bar PQ of length 50 cm is hinged at end P. The diagram shows the metal bar from above. Perfect. Two forces of 16 and 5 Newton are in horizontal plane and act on end Q as shown. Perfect. What is the resultant moment about P due to the two forces? We have to calculate the resultant moment about P due to the two forces. Okay, how can we do that? First of all, can you see this 5 Newton force is acting at a distance of 50 centimeter and it will be causing which type of moment? A clockwise moment. So let's calculate this first of all. 5 Newton into 50 centimeter, that is 0.5. This comes out to be 2.5 Newton meter. Perfect. Now let's resolve this 16 Newton force. This 16 Newton force can be divided into two components. One a vertical one and second being the horizontal one. The horizontal component passes through the pivot. The horizontal component passes through the pivot, hence its moment will be 0. However, the vertical component is what? 16 sine 30 and it is a distance of 50 centimeter away. This will cause an anti-clockwise moment. What will be the value of this anti-clockwise moment? Very easy. 16 sine 30 multiplied by what? 0.5. Let's calculate it. 16 sine 30 multiplied by 0.5. The answer comes out to be 4 Newton meter. You have to calculate the resultant moment. How do you calculate the resultant moment? Larger moment minus smaller moment. 1.5 Newton meter is your answer. This is question number 51. The answer to 51 in the marking scheme is A. Perfect. Okay, let's see this question. A shelf XY is 0.4 meters long and is attached to a wall at end X. It is horizontal by a wire attached to Y and to the wall. Perfect. As shown, the tension in the wire is 15 Newton at an angle of 30 degree to the horizontal. What is the moment of this force about pivot X? Okay, we have to calculate the moment of tension about pivot X. So if you focus, this tension can be divided into two components, one being the horizontal component, that is 15 cos 30, and one being the vertical component, that being 15 sine 30. The 15 cos 30 passes through the pivot, hence its moment will be 0. The only force that will be generating a moment will be this 15 sine 30. Perfect. So what will this moment be equal to? Moment is equals to 15 sine 30 multiplied by what? 0.4. What will this come out to be? 15 sine 30 multiplied by zero point 0.4. This comes out to be 3 Newton meter. A is your answer for 53. Your answer is A in the marking scheme as well. Okay, let's see this. Which statement best describes a couple? A pair of forces equal in magnitude, perfect, acting in opposite direction, perfect, and they produce rotation, perfect. A is your answer. B is incorrect. Why? Because it is saying no rotational motion. That is incorrect. Of equal magnitude acting in the same direction. This is incorrect. Of equal magnitude acting in the same direction. This is also incorrect. Perfect. Let's see. There's two forces each of magnitude F act along the edges of a rectangular metal plate as shown. The plate has a length A and width B. What is the torque about P? We have to calculate the torque about P. How can we do that? Force into the distance between the forces. So the torque will come out to be what? Torque is force into the distance between the two forces. This should be your answer. B is your answer. Okay, let's see this question. A trailer of weight 30 kilonewton is attached to a cab at X as shown in the diagram. Perfect. What is the upward force exerted at X by the cab on the trailer? Okay, so we have to calculate the upward force exerted here. Perfect. Let's take this as a pivot. Let's take this as a pivot. Okay. This 30 kilonewton force will cause a clockwise movement. This upward force will cause a anti-clockwise movement. Perfect. So what will be the clockwise moment be equal to? 30 into 10 raised to the power of 3 into 10. This comes out to be what? 30 into 10 raised to the power of 4 Newton meter. What will be your anti-clockwise moment? Anti-clockwise moment will be the force Fx into the distance, that is 20. Perfect. Let's equate both of them. Anti-clockwise is equals to clockwise. Anti-clockwise is what? 20 into Fx. Clockwise is what? 30 into 10 raised to the power of 4. Fx comes out to be what? 15 kilonewton. B is your answer. Simple. Let's see this. A uniform meter rule is pivoted at the 34 centimeter mark as shown. Okay, so this is pivoted at the 34 centimeter mark. The rule balances when a 64-gram mass is hung from a 4 centimeter mark. Perfect. What is the mass of the meter rule? So this is a uniform meter rule. Its mass will be acting exactly in the middle at the 50 centimeter mark. Whenever you have anything that is uniform, its weight act exactly in the middle. Okay. And this is a counterweight acting here, that is 64 grams. Okay. So let's calculate anti-clockwise moment is equals to clockwise moment. Okay. This weight will be generating a clockwise moment. Weight into the distance, that is 16 centimeter, is equals to anti-clockwise moment. This 64-gram weight will be generating a anti-clockwise moment. It is at a distance of what? 30 centimeter. And what is the mass? 64 grams. Can you calculate the weight here? Can you calculate the weight here? Yes, you can do that. 64 grams into 9.81, and this 64 grams will get divided by 1000 because we have to convert grams into kilograms. Perfect. 64 divided by 1000 into 9.81, perfect, into 30 divided by 16. This gives you weight of what? This gives you weight of 1.1772 Newton. And mg is equals to 1.1772 Newton. If you divide it by 9.81, the mass comes out to be what? 0.12. Mass is 0.12 kilograms. That is equals to 120 grams. C should be your answer. Let me see. 77 ka answer is C. Perfect. Correct. We are going good. Let's see this. A type of firework is made by connecting two rockets facing in the opposite direction to a rod as shown. Okay. The rod is attached to a frictionless pivot so that the fireworks can rotate in a vertical plane. The firework have weight W. The pivot exerts a force R on the rod that is equal and opposite to weight W. Perfect. Each rocket exerts a force of magnitude F on the rod at a perpendicular distance D from the pivot. Perfect. The force exerted by the rock are in opposite directions. Perfect. Air resistance is negligible. Which statement is correct? Okay, which statement is correct? The firework is in equilibrium? No, I don't think so. Firework is not in equilibrium because there is a torque acting here. This force and this force make up a torque which will rotate this in which direction? Which will rotate the rockets in clockwise direction. So all the options of equilibrium should be cancelled out. The firework is not in equilibrium because there is a resultant torque. D is your answer. So, which question is this? Yeah, the answer to it is perfectly D. Let's see this. Let's calculate the value of F. A uniform rod XY of weight 10 Newton is hinged freely to a wall at X. Perfect. It is held horizontal by a force F acting from Y at an angle of 30° to the horizontal as shown. Perfect. What is the value of F? We have to calculate the value of F. Very, very easy. First of all, let's resolve force F. There will be a vertical component of force F, that is F sine 30, and there will be a horizontal component of F, that is F cosine 30. This F cosine 30 passes through the pivot, hence the moment due to it will be 0. This F sine 30 will generate which type of a moment? An anti-clockwise moment. This 10 Newton will generate which type of a moment? Clockwise moment. So now let's calculate the value of F. Okay. If you further observe, this is a uniform rod. So the weight of 10 Newton will be acting at half the distance, let's say half D. And let's say the complete rod has a distance of what? D. Okay. Let's first of all calculate the anti-clockwise moment. Anti-clockwise moment is equal to what? F sine 30 into the distance, that is D. What are the clockwise moments? Clockwise moments are 10 into half D. Let's equate both of them. Anti-clockwise is equals to clockwise. F sine 30 into D is equals to clockwise. That is 10 into 1 upon 2D. D and D cancelled out. This becomes 5. F is equals to 5 divided by sine 30. Let's calculate that. 5 divided by sine 30. 1 second. This gives you an answer of 10. Your answer should come out to be 1087, should have an answer of C. In both the cases, a string is attached to the same point on the picture and looped symmetrically over a nail. The forces shown are those that act on the nail. Perfect. In diagram 1, the string loop is shorter than in diagram 2. Which information about the magnitude of the forces is correct? Okay, which information about the magnitude of forces is correct? One thing that you can see right off the bat is the weight W is acting here and the weight W is acting here. R1 will be equal to weight and R2 will also be equal to weight. Hence, R1 will be equal to R2. Perfect. So, C and D options get cancelled out. Now, let's zoom in a bit. Let's zoom in a bit and let's apply some logic here. Let's say this is angle theta 1 and let's say this is angle theta 1 as well. Perfect. Can you resolve these tension vectors? Yes. These tension vectors act downward like this. This comes out to be what? T1 sine theta 1 multiplied by 2 because there are two tension vectors like these. Now let's say you have this as theta 2 and this as theta 2. Perfect. You can resolve these tension vectors like this. You can resolve these tension vectors like this. T2 sine theta 2 multiplied by 2. Perfect. Can you realize that here this 2t1 sine theta 1 is equals to what? R1. And here 2t2 sine theta 2 is equals to R2. And you have just now proved that R1 and R2 are equal to weight. So let's replace that. 2T1 sine theta 1 is equals to weight, and 2T2 sine theta 2 is also equals to weight. Perfect. Now observe the magic. Now let's say I bring this 2T1 to the downside. Sine theta 1 is equals to W over 2T1. Can you observe that W and T are constant? Can you observe that W and T are constant? Yes. What will happen? Sine theta 1 will be inversely proportional to T1. Can you see that theta 2 is evidently greater than theta 1? Hence, sine theta 2 will be evidently greater than sine theta 1. And sine theta and tension are inversely proportional. So the tension in 1 will be greater than the tension in 2. B is your answer. For 89, B is your answer. Let me zoom out if you want to take a screenshot of this working. Okay, let's see this question. A probe is used to monitor the quality of water in the sea. The probe is suspended by a vertical string which is attached to a sphere. The stationary sphere, perfect, floats in equilibrium on the surface of the sea as shown, perfect. What does the word of stationary tells you? That the up forces will be equal to the down forces. Simple as that. The sphere has a weight of this. The probe and the string have a combined weight of this. Perfect. The density of seawater is this. The upthrust acting on the probe and the thread is negligible. What is the volume of the sphere below the surface of water? You have to calculate what is the volume of the sphere, this thing, below the surface of the water. Now, how can you calculate that? Very easy if you know how to mark the forces. Very easy if you know how to mark the forces. First of all, what can you say here? You can say the weight of the sphere and the weight of the string acting downwards. These are both weights. W1 and W2 is equal to the upthrust that is acting upwards. So W1 plus W2 is equals to the upthrust. What is W1? Weight of the sphere? 5 Newton. What is W2? The weight of the strings? 2 Newton. What is the upthrust? Density of the liquid, that is 1.03 into 10 raised to the power of 3 multiplied by gravitational field is 9.1 into the volume of the object. Can I calculate the volume of the object? Yes, 7 divided by 1.03 into 10 raised to the power of 3 into 9.81 is equals to your volume of the object. So 7 divided by 1.03 into 10 raised to the power of 3 multiplied by 9.81. This comes out to be what? 6.92 into 10 raised to the power of minus 4. D is your answer. Let me check the question. 91. The answer to 91 according to the marking scheme is D. Perfect. We are going. Let's try this out. A diving board of length 5 meters is hinged at one end and supported 2 meters from this and by a spring constant 10 kilonewton. Perfect. So this is the spring of a spring constant 10 kilonewton. A child of mass 40 kgs stands at the far end of the board. Perfect. What is the extra compression of the spring caused by the child standing on the board, on the end of the board? Perfect. So we have to calculate the extra compression. Okay, we can do that. First of all, realize that this person or this child will be exerting a weight downward that is equals to what? 40 kg mass multiplied by 9.81. This comes out to be what? 40 into 9.81. This comes out to be 392.4 Newton. Perfect. This will cause what? This will cause an anti-clockwise moment. This will cause an anti-clockwise moment. Perfect. Okay. This will be balanced by what? This will be balanced by the spring. This will be balanced by the spring, causing a force downward, and this will cause a clockwise moment. This will cause a clockwise moment. Okay. So, first of all, let's equate the anti-clockwise moment to clockwise moment to find out the force of the spring. What will be the anti-clockwise moment? 392.4 multiplied by the total distance, that is 5, is equals to clockwise moment, that is force, into the distance, that is 2. Force comes out to be what? 392.4 into 5 over 2. Let's calculate that into 5 divided by 2. The force comes out to be what? Force comes out to be 981. Perfect. 981 is your force. Perfect. 981 Newton you can write here. Now your spring constant is what? 10 kilonewton per meter. Perfect. So let's apply this equation. F is equals to Ke. Your force is what? 10 into 10 is the power of 3. Sorry, your force is what? My bad, my bad. Your force is 981. Your K is 10 into 10 raised to the power of 3 multiplied by extension. So answer divided by 10 into 10 raised to the power of 3. What will your extension come out to be? Your extension comes out to be 0.0981 meters. 1 2 decimal forwards, 9.81 centimeters is your answer. C should be your answer for 95, and it is C in the marking scheme. Perfectly fine. Okay, let's see this question. A uniform rod of 200 centimeter is freely pivoted at P. So your pivot point is what? P. Perfect. The rod is held horizontally in equilibrium by a 60 Newton weight that is attached to the rod by a string passing over a frictionless pulley. Perfect. So this is the 60 Newton weight. Perfect. This 60 Newton weight will cause a tension here that is equals to 60 Newton as well. This string will also have a 60 Newton tension. Perfect. Can you divide this tension force into two components? Yes, this will become 60 cos 30, and you will have a vertical component that is what? 60 sine 30. Perfect. Okay. And one more thing, this vertical component will be acting at the same point from where the diagonal tension was acting, that is 60 sine 30. This is a uniform rod. So where will the weight be acting? Weight will act exactly in the middle. That is, you will have 100 centimeter from here. If anything is uniform, its weight act in exactly the middle. Perfect. This weight will cause movement in which direction? In the clockwise direction. This 60 sine 30 will cause movement in which direction? Anti-clockwise direction. So let's equate anti-clockwise moment is equals to clockwise moment. Okay. What is the anti-clockwise force? Okay, how to calculate the anti-clockwise moment? You take this force, that is 60 sine 30. Now please be careful here. You have to take the distance from pivot P. This will be what? This will be what? This entire thing will be what? 160. Sir, how do you know that? The total length is 200. Subtract 40 from it. It will give you 160 centimeters. That is 1.6 meters. Is equals to the clockwise moment. Clockwise moments are equals to what? Weight multiplied by what? Weight multiplied by this distance. That is what? 100 minus 40. That is 60. That is 0.6. Weight comes out to be what? 60 sine 30 into 1.6 divided by 0.6. Can we calculate this answer? Yes, 60 sine 30 into 1.6 divided by zero point 0.6. This gives you an answer of 80 Newton. Let me check the question number. 99 should have an answer of C, and it has an answer of C. Perfectly fine. Okay, let's see this question. An object of weight 120 Newton is supported in equilibrium by two strings as shown. Perfect. What is the tension T1 in the left hand side of the spring? You have to calculate this T1. Let's say the tension here is T2 as well. And now let's split up these tensions. This is the horizontal component of T2, T2 cos 20. And this is the horizontal component of T1, that is T1 cos 70. There will also be vertical components. This is the vertical component of T1, that is T1 sine 70. And this will be the vertical component of T2, that is T2 sine 20. Now let's create simultaneous equations. First of all, in the horizontal direction. In the horizontal direction. And let me tell you, there is an easy way to do it as well, but let's first of all see the hard way. Horizontal plane. In the horizontal plane, your right force, that is 2t cos 20, is equals to the left force, that is t1 cos 70. Okay, so cos 70 divided by cos 20, this gives you an answer of what? 0.t2 is equals to t1 0.364. T2 is equals to 0.364 T1. Perfect. Now let's consider the vertical plane. Let's do the working in the vertical plane. Okay, so in the vertical plane, what are the upward forces? T1 sine 70 plus T2 sine 20. And this force is acting downward, so we will place a negative sign with it, is equals to 0. Perfect. Now we know that T2 is equals to what? 0.364 T1. So let's place it here. T1 sine 70 plus 0.364 T1 sine 20 minus 120 is equals to 0. Okay. Now let's calculate the combined T1 0.364 into sine 20. Okay, plus sine 70. Okay, this gives you an answer of what? 1.064 T1 is equals to 120. Can you calculate T1? Yes, 120 divided by 1.064. 120 divided by answer. This gives you 112 newtons or 113 newtons as your answer. The answer 2104 is C. This marks the end of the past papers for forces. If you have any questions, you can ask in the comments below.